Hi there. Today we are doing a realistic DevOps interview focused on certificates, TLS, and expiry incidents. This is one of those topics that looks simple on paper and then quietly takes production down at 3 in the morning. I want you to treat this like a real interview. Pause the video after each question, say your answer out loud, then listen to how a strong candidate might think through it. This is not about memorizing definitions. It is about how you reason under pressure. If this style helps you prepare for real interviews, subscribe so you do not miss the next one. Tell me about a time you were involved in a production incident related to security or availability. A strong answer here usually starts with context and impact. For example, I was on call for a platform team supporting several internal services. One night we started getting alerts that multiple APIs were failing health checks. Customer traffic was being rejected. I quickly narrowed it down to TLS handshake failures. The root cause was an expired certificate on an internal load balancer that was not covered by our existing alerting. I coordinated rollback options while another engineer rotated the certificate manually. After recovery, I focused on preventing a repeat by adding certificate expiry monitoring and documenting ownership. What matters here is showing calm response, collaboration, and learning from the incident. How do you usually balance speed and safety when making changes related to security? A good candidate will avoid extremes. You might say that I try to build safety into the system so speed does not require heroics. For certificates and secrets, that means automation, short-lived credentials, and clear ownership. When changes are needed urgently, I follow a checklist and get a second set of eyes if possible. In calmer times, I invest in tooling so future changes are low risk. This shows maturity rather than bravado. Describe a situation where you had incomplete information during an outage. How did you proceed? A strong response sounds thoughtful. For instance, during an outage, I rarely wait for perfect data. I form a working hypothesis based on symptoms and test the lowest risk actions first. If TLS errors appear across many services at once, I suspect shared infrastructure like a proxy or certificate authority. I communicate uncertainty clearly to stakeholders and update them as I learn more. This demonstrates structured thinking under ambiguity. How do you communicate technical incidents to non-technical stakeholders? Good candidates show empathy. You might explain that I avoid jargon and focus on impact, current status, and next update time. For a certificate expiry incident, I would say secure connections are failing, users cannot access the service, and we are rotating credentials now. I only go deeper if asked. This builds trust without overwhelming people. Let us start simple. Can you explain what a TLS certificate is and why it exists, but explain it the way you would in a real interview? A strong answer avoids textbook language. You might say a TLS certificate is how a service proves its identity to clients and establishes encrypted communication. When your browser connects to an API, the certificate helps verify you are talking to the right service and not an imposter. It also enables encryption, so data is not readable in transit. In practice, certificates tie together trust, identity, and encryption, and when they fail, traffic usually fails hard. Now imagine this scenario. At midnight, several services start returning TLS handshake errors. What is the first thing you check and why? A solid answer walks through reasoning. I first check whether the failures started at the same time across services. If they did, I suspect a shared dependency like an ingress, load balancer, or service mesh. I would look at certificate expiry dates for those components and recent changes. I might also test connectivity directly with tools to confirm whether the certificate presented is expired or mismatched. The goal is to quickly confirm whether this is a certificate issue versus a networking or DNS issue. How do certificate expirations actually happen in modern environments that use automation? This is where experience shows. A strong candidate might say that expirations often happen at the boundaries of automation. Maybe production uses automated renewal, but staging does not. Or the certificate was manually installed years ago and forgotten. Sometimes automation breaks silently due to permission changes or API limits. The key point is that certificates expire because ownership is unclear or monitoring is missing, not because people forgot the date on purpose. Let us talk about trade-offs. Short-lived certificates are often recommended. Why are they good, and what problems do they introduce? A thoughtful answer weighs both sides. Short-lived certificates reduce blast radius if compromised and force automation to work correctly. But they increase reliance on renewal systems. If renewal fails, outages happen faster. They also add operational complexity when debugging because certificates rotate frequently. A strong engineer designs alerting and fallback mechanisms to handle this trade-off rather than avoiding short lifetimes entirely. Here is another scenario. You rotate a certificate, but some clients still fail with trust errors. What could be happening? A strong answer explores multiple possibilities. Clients might be caching the old certificate or chain. Intermediate certificates might be missing or changed. Some clients may not trust the new certificate authority. In service mesh environments, sidecars may need reloads. The key is to show that you think beyond just replacing the certificate file and consider the full trust chain and client behavior. Finally, for this section, how would you design monitoring to prevent certificate expiry incidents? A good answer focuses on outcomes. I would monitor certificate expiration dates with alerts at multiple thresholds, not just one. I would ensure ownership is clear so alerts go to the right team. I would also monitor actual handshake success rates because expiry is not the only failure mode. The goal is to catch both the known risk and the unknown ones early. That concludes this portion. Pause here, reflect on which questions felt uncomfortable, and get ready for the next set where the scenarios get tougher. Let us go deeper now. Imagine you inherit a platform with hundreds of certificates across load balancers, internal services, and third-party integrations. There is no single source of truth. How do you approach understanding and stabilizing this without breaking production? A strong candidate usually starts by reducing risk before changing anything. I would begin by inventorying what exists, even if it is imperfect. That might mean scanning endpoints to see which certificates are presented, pulling data from cloud provider APIs, and reviewing any existing documentation. I am not trying to redesign yet. I want visibility. Once I know what certificates exist, where they terminate, and who depends on them, I can start identifying the riskiest ones. Expired or near-expiry certificates get attention first. Only after I have monitoring and basic ownership in place do I start standardizing tooling or automation. This avoids the common mistake of trying to clean everything up at once and causing outages. Here is a scenario. A certificate expired even though automated renewal was configured. Post-incident review shows the renewal job failed silently weeks earlier. How do you design systems so this does not happen again? A thoughtful answer focuses on layered defenses. I would not rely on a single automation path. Renewal success should be observable, not assumed. That means alerts if renewal jobs fail, alerts if expiration dates cross thresholds, and alerts if handshake errors increase. I would also ensure renewal failures surface loudly, not just in logs no one reads. In some environments, I add synthetic checks that simulate a real client connection. The idea is that expiration should never be the first signal. Something should scream long before that. Let us talk about trust chains. Can you walk me through what happens during a TLS handshake at a high level and where things commonly go wrong in production? A strong answer sounds practical. When a client connects, the server presents its certificate along with any intermediate certificates. The client checks that the certificate matches the host name, is not expired, and chains back to a trusted route. In production, failures often come from missing intermediates, hostname mismatches after DNS changes, or clients that do not trust the same root CA. Sometimes the certificate itself is fine, but the chain is incomplete. Understanding this helps debug issues faster than just rotating certificates blindly. Now consider mutual TLS between services. What are the operational risks compared to standard TLS, and when is it worth it? A mature answer balances security and complexity. Mutual TLS gives strong identity guarantees between services, which is great for zero trust models. But it doubles certificate management because both sides need valid certificates and rotation. It also complicates debugging because failures can happen on either side. I usually recommend MTLS when the threat model justifies it and when there is solid automation in place. Without automation, MTLS can increase outage risk more than it reduces security risk. Another scenario, you rotate a certificate authority used internally. Some services recover immediately, others fail intermittently for hours. What do you suspect and how do you investigate? A strong candidate thinks about propagation and caching. I would suspect that some services are still using old trust bundles or have not reloaded their configuration. In containerized environments, pods may need restarts to pick up new CA bundles. Some languages cache trust stores at startup. I would compare failing and healthy services to see what differs. The key is recognizing that rotating a CA is not instant and planning for phased rollout and rollback. Let us discuss trade-offs again. Centralized certificate management versus team-owned certificates. What are the pros and cons? A good answer avoids absolutes. Centralized management reduces inconsistency and makes monitoring easier. It works well for shared infrastructure like ingress or API gateways, but it can become a bottleneck if teams need flexibility. Team-owned certificates allow faster iteration, but increase the risk of drift and missed expirations. In practice, I like a hybrid model where the platform team provides tooling, automation, and guardrails, while teams own their specific certificates within that framework. Final question in this section. How do you test certificate changes safely before they hit production traffic? A strong answer shows caution. I prefer to validate certificates in staging environments that closely mirror production. I test hostname matching, chain completeness, and client compatibility. For production, I often use canarying by attaching new certificates to a subset of traffic or endpoints first. I also monitor handshake errors closely during rollout. The goal is to make certificate changes boring, even though historically they have caused some of the worst outages. Take a moment here. These questions are less about memorization and more about how you think through risk, ownership, and failure modes. In the next segment, we will push into judgment calls where there is no perfect answer. Now let us turn up the pressure a bit. Imagine it is a weekday morning. Traffic is dropping fast. Customers report browser warnings about insecure connections. You discover a public-facing certificate expired 10 minutes ago. Renewal automation exists but failed. What do you do in the first 5 minutes? A calm answer focuses on restoring trust before fixing root causes. My first action is to get a valid certificate live as fast as possible, even if that means manual issuance. I would prioritize the highest traffic endpoints first. While that is happening, I communicate clearly to stakeholders that we have identified the issue and are actively mitigating it. I am not debugging automation yet. Availability and user trust come first. Once traffic stabilizes, then I look into why automation failed. Here is a harder one. You are in the middle of an incident. A teammate suggests temporarily disabling TLS verification on clients to restore traffic. It would work. What is your response? A mature response weighs short-term recovery against long-term damage. I would push back carefully but firmly. Disabling verification introduces real security risk and may violate compliance requirements. I would ask how long the workaround would be in place and what data would be exposed. If there is no safer alternative and the business impact is catastrophic, it might be considered with executive sign-off and clear rollback conditions. But in most cases, I would look for safer options like rolling back to a known good certificate or routing traffic differently. Another scenario. Your monitoring warned about certificate expiry weeks ago, but the alert was ignored. Now, leadership wants to know who is responsible. How do you handle this conversation? A strong answer avoids blame. I would focus on systems, not individuals. I would explain what signals existed, how they were routed, and why they did not result in action. Then I would propose concrete improvements like clearer ownership, escalation paths, and alert severity changes. The goal is to reduce the chance of recurrence, not to punish someone for missing an alert in a noisy system. Let us go deeper. You manage certificates for multiple teams. Some teams want longer-lived certificates to reduce operational overhead. Security wants very short lifetimes. How do you decide? This is a classic trade-off. I would start by understanding the threat model and the cost of rotation failures. Short-lived certificates improve security but increase operational risk if automation is brittle. Longer lifetimes reduce rotation risk but increase blast radius if a key is compromised. I would likely choose shorter lifetimes for external and high-risk systems, and slightly longer lifetimes internally where automation is proven. The key is aligning certificate policy with actual risk, not ideology. Final pressure question. You are asked to migrate all certificates to a new provider within a tight deadline. There is no time to test everything perfectly. How do you approach this safely? A thoughtful answer emphasizes sequencing and rollback. I would identify the most critical paths and migrate those last, not first. I would run both systems in parallel where possible and validate behavior incrementally. I would also ensure we can quickly revert to the old provider if something breaks. When time is limited, safety comes from controlled rollout and the ability to undo changes, not from hoping everything works. Take a moment to reflect on this interview. Certificates and TLS issues rarely fail loudly at first. They fail quietly, then suddenly, and often at the worst possible time. Think about which questions challenged you the most. Was it the technical details of trust chains, the operational complexity of rotation, or the judgment calls during incidents? Pause the video and answer those questions out loud. That is how you build confidence for real interviews. If you found this useful, subscribe for the next interview in this series. We will continue exploring real-world DevOps scenarios that test not just what you know, but how you think under pressure. And let me know in the comments which question was the hardest for you.